Hi, this is Alfozia Nihar from At Home Tuition. Welcome to our session today. The topic that we are going to discuss in our today's video is inverse of a rational function. Finding the inverse of a rational function is relatively easy, although it can be daunting at first. You will get comfortable as you study along. In this video, we can discuss 5 examples that will help you gain basic understanding on how to approach the rational function inverse. You may realize later that the procedure to find the inverse is rather repetitious. That means once you get the hang of it, you got it. Not a bad thing, right? Please keep in mind that the method used here is just one way out of the many. Feel free to vary the steps to fit your needs as long as you're getting the same final answer. Let us begin with key steps in finding the inverse function of a rational function. Step 1. Replace f of x by y. Step 2. Switch the roles of x and y. In other words, we just have to interchange x and y in the equation. Step 3. Solve for y in terms of x. That is, we are going to isolate y on one side of the equation and shift all the other terms to the other side of the equations. Finally, step 4. Replace y by f inverse of x to get the inverse function. These are the key steps in finding the inverse of a rational function. Please go through the steps. Now we can discuss examples one by one and show you step by step how to find the inverse of a rational function. Please look at the question. We are asked to find the inverse function and state its domain and range. Please look at the function given 2 over x plus 3, and it is given that x is not equal to negative 3, or else the denominator would become 0. So even without graphing this function, we can know that x cannot be equal to negative 3 because the denominator will become 0 and the entire rational expression becomes undefined because any number or any term over a 0 will become undefined. So in fact, domain is all values of x, not including this negative 3. We are just going to exclude the negative 3 from the set of all real numbers, and that would be your domain. Next, we need to graph this function to verify if it passes the horizontal line test. Hope you remember the horizontal line test. In case if you draw a horizontal line on the graph, it should touch the graph at only one point, not more than 1 point. Only then we can say that the function satisfies the horizontal line test or passes the horizontal line test. Then in case if it does not pass the horizontal line test, then we can say that the function is not one-to-one and it has no inverse function. So we can be guaranteed to have an inverse function once it passes the horizontal line test. Here is the graph of the function. Please look at the graph. So it seems that no horizontal line will intersect the graph more than once. That's a good sign. The vertical dashed line is called a vertical asymptote. The graph will never cross that. Please remember, it is coming from the zeros of the denominator. Okay, or the restricted values of x. So using the suggested steps, let us find the inverse of this function. Okay, first replace f of x by y. Then just interchange x and y. I'm going to swap the roles of x and y here. Multiply both the sides by LCD. Here the denominator is y plus 3. Multiply both the sides by y plus 3 so that we can get rid of the denominator. Distribute x. Subtract 3x from both the sides. Divide both the sides by x. Replace y by f inverse of x. Domain has to be x not equal to 0 and range has to be y not equal to negative 3. The domain of the inverse function comes from the fact that the denominator cannot be equal to 0 and the range is obtained from the domain of the original function. Does this make sense to you? This is how we find the inverse of a rational function. Okay, this is a very basic example. Let me take another example and show you. Please look at this example, x plus 5 over x minus 5. By looking at the function itself, we can say that we may not need the graph because the numerator and denominator of the rational expression are both linear. So based on the experience, we can make sure that this will have an inverse because it can pass the horizontal line test. The rest of the work is simply algebraic. Okay, let me show you the graph anyway and explain you the same way as we solved the previous example. Here is the graph. Please have a glance over this. As we solve, we will encounter terms with variable y in both the sides of the equation, and our task is to move all the y terms on the left side. Though you can gather it on the right, I'm just making sure that we are going to isolate y on one side of the equation. For this example, I'm going to shift it to the left side and then factor out the y to single it out. Okay, let's apply the steps. Replace f of x by y equal to x plus 5 over x minus 5, and then cross multiplication or multiply both the sides by x minus 5. So before cross multiplication, let us interchange x and y. So the left side would become x, y plus 5 on top and y minus 5 on the bottom. Now multiply both the sides by y minus 5. So we will get distribution. So x times y is xy and x times negative 5 is negative 5x. Shift this 5x to the right side and shift this y to the left side by subtraction. So I'm going to subtract y from both these sides and add 5x on both these sides. Now take y as a common factor out and x minus 1 will be the leftovers. Now you can divide both these sides by x minus 1. So you will get 5 plus 5x plus 5 divided by x minus 1. Replace y by f inverse of x. Since we cannot permit to plug in x is equal to 1 in the denominator, that literally becomes the domain. That is all the x values excluding x is equal to 1. So we can take the domain of the original function to make the range of the inverse. That's it for this example. Okay, let me take one function where the denominator is just x. Here is the next example, and I have shown you the graph of the original function. Please have a look over that. Now I'm going to apply the steps for finding the inverse. First, replace f of x by y and then swap x and y. So you will get 2y and in the denominator y, and then just cross multiply. So you will get, okay, let x be here so that we can shift the y terms on one side and x terms to the other side. Now add 2y on both these sides. So you will get yx minus 2y equal to 7. Take y as a common factor out and write down the leftovers within the parenthesis, and then divide the equation throughout by x minus 2. Finally replace y by f inverse of x. So if you equate the denominator, if you replace the x to 2, you will get the denominator equal to 0. So it means that you have to exclude the negative 2. So if you set this equal to 2, you'll get positive 2. Okay. So if you shift, it will become positive, and finally this would also become positive. If you set the denominator equal to 0, you will get x is equal to negative 2. So you have to exclude this from the domain. Am I right? So excluding negative 2 from the set of all real numbers, the remaining would be your domain for this one. And what about the range? Range is nothing but y is not equal to 0. Hope you're clear with this example. Okay, now let me take one more example. Here is the next example. Please read the function 7x plus 1 in the top row, negative x plus 9 in the bottom row, under the condition x is not equal to 9. Please look at the graph for this function. So this is the graph for the original function. So maybe when you look at this problem, you already have a quick thing how to approach it now. That is usually the nature of any math problem. Learn the concept by going over some worked example while highlighting the critical steps. So since the rational expression has linear terms in both numerator and denominator, please be convinced just like in previous example. That is, it will have an inverse function even without further testing. Keep it in your experience and utilize it as your advantage whenever you encounter similar problem. So just to verify, the graph is shown. The steps to find the inverse function is the same. Towards the end of the solution, we clean up the final answer by factoring and then cancelling the hidden negative 1. found in both numerator and denominator. So you will learn how to do it as you gain experience, or maybe with the use of the little sense. Let me show you the steps. Replace f of x by y. So, and then swap x and y. So you will get x is equal to 7y plus 1 minus y plus 9. Now let us multiply both the sides by negative y plus 9. Distribute left side. Shift 9x to the right side by subtracting 9x, and shift 7y to the left side by subtracting 7y. Take the common factor y outside and write the leftovers negative x negative 7 within a parenthesis. Divide both the sides by negative x negative 7. Now, did you notice that there is a negative sign before the first terms, I mean the x terms? Now we have to clean it up by factoring negative 1 on the top and then bottom. So if I take negative 1 as a common factor outside, I'll get negative 1 times 9x minus 1. Same way, if I take negative 1 outside as a common factor for the two terms in the bottom row, I'll get x plus 7 in the bottom. Am I right? So both can be cancelled out because negative over negative is a positive 1. So you'll be left over with this. Am I right? Finally, replace y by f inverse of x. So if you set the denominator equal to 0, by solving for x, you'll get negative 7. So you should exclude that negative 7 from the set of all real numbers. So what would be the domain for this one? X. X is not equal to negative 7. And range is obviously y is not equal to negative 9. The domain of the original function. I hope you agree with the domain and range. If not, you can just swap the domain and range and check for the clarification. Please remember that domain and range of a given function and its inverse are interchanged. Hope you're clear with all the examples we discussed in this session. In case if you have any query, kindly let